You know, where we're standing right now is pretty great. You can see the Williamsburg Bridge and you can see all of Manhattan. You know, on any of these floors where you have this view, you're going to be in a special spot. This is a site that was originally used to refine sugar for the Domino Company and was closed in early 2000. And it sat dormant for many years. I think it's a really important thing that we use these assets that are really unique and special to Brooklyn in great ways, and I think we're doing that here.
So the Domino Site A project, basically half commercial, half residential, new construction, but on the site of what was an industrial site. Trying to tie that new use to a previously industrial site is a challenge. How do you make a building feel like it belongs in a specific place? Specifically for the exterior wall, how can we come up with something that really reflects the place it's from and some of its history, and as well as being part of its future? That brought us to the idea of sugar and dealing with sugar. They have quite a unique form to them. They have a little bit of chamfering that catches the light, almost like a cut diamond. And so we were interested in creating a facade that would really be animated, but reminiscent of the reflection and form of sugar crystals. One of the reasons we started looking early on at precast concrete manufacturers was because we knew the materiality was going to be very important to create the sharp lines and the different textures of the facade that we were looking at, to get the reflection and the shadow and the detail, which is what the whole design was about. The solution to that Gate really came up with. They proposed that we could have far more rapidly made and reusable forms that would create the articulation that we wanted if we used this large format 3D printing to create the molds.
We're presently in the storage area of our plant. This is where all the product comes after it's been manufactured, finished, and is waiting to be delivered. This job, with the size of it and the amount of window openings, it lends itself to more, I guess, repetition on the molds. It was decided early on that we would look at a new technology, 3D printed molds. Typically in architectural precast, a lot of our molds are just used once to maybe 3 to 4 times, and then they're thrown away. So almost all of our molds are made out of wood. And these 3D printed molds, we can get 150 to 200 castings on them. The 3D mold does allow for a lot more complex shapes. We've got a lot of angles on these window openings. We can change shapes going from angles to curves with 3D forms, which would be very difficult to do with wood. So it opens it up for the architects now to create almost any shape that they want.
We brought the design into Revit during the competition phase. That model then went on to create the design documentation for the project and the actual construction documents. Early on in that phase, we started to share that model with the precast manufacturer, going back and forward as their engineers were telling us we need a bit more depth here, we can go a bit thinner here, and how many window modules can we string together in the one panel to really make it most optimized for the crane lifts. And then ultimately from Gate became the model from which the 3D printed molds came from.
The manufacturing process would start with putting in the reinforcing rebar, the hardware, connection hardware, bearing hardware, window inserts. Once all that is set, then we pour our concrete into the mold. Usually sets for about 10 to 14 hours to cure. Once it's cured, the next morning we'll strip the piece out. The piece is carried out into our finishing area where we tilt it up, and that's where we acid wash it first, and then we polish the front face. Once that's completed, then we move it into storage, and eventually gets moved into the window installation area where they'll install the windows and caulk the windows prior to being shipped to the job site.
Without the 3D printed molds and without that technology, it would have been impossible to create the forms that we wanted on the schedule that was necessary for this project.
Of course, you always get nervous when you got 18,000 pounds hanging from hooks. The product is fabricated for the most part. We still have a few pieces here and there. So now it's the matter of execution at the job site. The biggest challenges on this project really is just the logistics of it. We're pulling this product from Kentucky and Oxford. Being able to get the product here in a timely fashion to where the erector can make the counts he needs to make in order to meet schedule has been a challenge. If we had to build molds out of wood, we would still be building molds.
We're manufacturing off-site while the structure of it's being constructed on-site. So once we get to the job and with the windows installed, you can have an enclosed envelope 50% quicker than you could with maybe some other materials.
I think it's been very exciting the last few years that buildings are starting to express the fact that they are precast and it's not hiding it anymore. It's using the possibilities of that material as its own, as opposed to mimicking something else, and how much of a design tool it will be for us to create different shapes and forms more affordably.
Well, I see 3D molds being another tool in our toolkit, be able to fabricate the pieces that architects would like to see and owners would like to see. And I think it will just gain more and more momentum, especially after this job is completed.
I think as you take this in, you really appreciate both the form and the texture of the facade. You're definitely going to appreciate the landscape and the park and the views of the city. It's a really special and unique place, and I think you're going to recognize that the moment you come here.